All right, so in this video, I'm going to take you through the steps to prepare your model for 3D printing using the slicer function or feature from Fusion 360. All right, so in this example, we're going to print the calibration bunny right here. Okay. Before we start with that, there's a couple of preliminary things that I need to talk about. First of all, I want you to note the orientation of the model. Okay, so this is going to be important later on when we get into the slicer. But you'll notice that the Z direction of my model is to the left and Y is up. Okay, that's not really important for the model, but it is going to play a role when we get into the slicer, and you'll see why when we get there. The other thing is we need to make sure that we are dealing with a component. That is to say, our 3D model is represented as a component in Fusion. The calibration bunny right now, if I go over to the browser, you can see that there's no components and it's only represented as a body. All right. So in order to convert this to a component, I'm going to move over to body 1, right click and say create components from body. And then there's my component right there. Okay, so that's the preliminary steps needed to get the model ready for the next stage, which is the slicing stage. Now we want to go to the manufacture workspace. And that's going to take us into basically the CAM area, or computer aided manufacturing area, where we're going to prepare the model for manufacturing, whether that's metal cutting, whether that is laser cutting, or in this case, it's going to be 3D printing. 3D printing is known as additive manufacturing, and so you'll see the additive tab right here. That's the one that we want to be working with, additive. And the first thing that we're going to do is we're going to go to setup. All right, so we choose setup, and what we need to do here is we need to first of all choose or select the type of 3D printer that we're going to be using for this. Now, the primary 3D printer that we're going to be using in class is the Creality Ender 3 Pro. So I'm going to move over to the right menu here and select Machine, and then I'm going to choose additive on the right hand side, and I'm going to put a check mark in FFF for fused filament fabrication. That's the that's the 3D printing, that the type of 3D printing that we're going to be using. So I click on that, and now I want to scroll down and find the Creality Ender 3 Pro, which is right. Oh, where did it go? There it is, Creality Ender 3 Pro. Okay. On the right-hand side, you can see some info about it. The only important thing here is that the machine dimensions here, X 220 millimeters, Y 220, and Z 250, is the build volume that you're allowed with the Creality Ender 3 Pro. This is basically 8 inches by 8 inches by 10 inches high. Okay. So we're going to select that. And the next thing that we need to do after we select the machine is we need to go to our print settings. And we go to our print settings, and this is going to list the material, the filament diameter, and the layer height, and also nozzle diameter for the operation that we want to use to build, in this case, the calibration bunny. You can see that we have different filament types. This is ABS, this is a breakaway material, this is CPE, which is a flexible material, PLA+, PLA, and PVA. Now for this example and for other prints with the Creality Ender 3 Pro, our filament diameter is always going to be 1.75. Okay, the nozzle is 0.4 millimeters, right? We are not going to be printing with ABS material with those printers. We have other printers for ABS material. So we're going to choose the PLA 1.75 0.4 millimeter nozzle with the 0.2 millimeter layer height. So I choose that one. I say so. Oh, and before we do that, let's just look over here on the info. There's some other information here, such as the extruder 1 temperature 220 degrees Fahrenheit. We don't have an extruder 2, so you can ignore this. The infill pattern is gyroid, okay, and the infill density is set to 15. All right, all this stuff we can change later. So let's select. And finally, we want to go to the model and select the model that we want. Now, in this case, there's only one model, so it defaults to that model. If there were other models, then I'll take that away, and we can go over here to the browser and click on the triangle there, and then we can just click on the calibration button, or you could just pick it, okay? And then we say okay, and there we go. All right, now, you'll notice the orientation here is a little bit odd. And if you remember back to the beginning when we were noting the orientation of the model in the design workspace, you'll notice that here Z is again to the left, but notice that the build area, right, this area right here, seems to be laying on its side. And that's because for the 3D printers, Z is always going to be up. So what it might be helpful to orient this in the orientation that it's going to print. So let me show you how you do that. So I'm going to click on the right view here on my view cube. And then I'm going to go over to these arrows, and I'm going to click the arrow to rotate it one direction clockwise. And then I can go up to the corner to choose the isometric view. And that's going to give me a little bit more of a normal view, although now my model is laying on its side, okay? And this is going to take us to the next stage in our model preparation, in our slicing, which is to choose the position that we want the model, all right? Now, from the position tab, you can see we have a number of different commands. Okay, so under position, you can see that we can position the model to minimize build height. Let's click on this just to see what it does. So I choose click on build height. It says select the component. I'm going to pick that object and say okay. And then it doesn't do anything, right? Well, it doesn't do anything because it's already oriented to minimize build height. Build height is one of the determinants for the duration of your 3D print. It's not the only determinant, but it's one of the main ones. So if you want your 3D print to print faster, minimize your build height, okay? Let's go to the other one, automatic orientation. Let's choose automatic orientation and see what happens. So we choose automatic orientation. We can set the different parameters here. I'm not going to set anything, but I'm going to leave it by default, and I'm going to click on this and say okay. And again, nothing happens because this is automatically in the orientation because this was by default. Now, actually, what I want to do is I want to print this sitting up in its normal orientation. So to do that, I'm going to go to the move command here. And I'm going to select this component, and I'm going to rotate it like this, okay, and say okay. Now notice it turned red. So when you get a red component here, it means that the component is violating some physical space in the build volume. And you can see that the bunny, in this case, is in the build platform. So that's not going to be good. So I'm going to use this command right here, place parts on platform. You can see it right there. And I'm going to set it on the platform directly on it with an offset of 0 millimeters. So I'm going to choose my object. I say OK, and it bumps it up a little bit. And we can see that here. You can see it's sitting right on top. Okay. So I'm happy with this orientation. Okay. So I'm ready to move on to the next step. Now we're going to skip the print settings, infill, and support areas. Some of this you may want to change, but it's going to require experimentation, especially if you're using other materials other than PLA. Okay, so I'm not going to go through that right now. That's kind of a advanced step that that we can sit down and discuss and kind of play around with. But right now, I'm ready to just go ahead and generate the G-code, okay, or the toolpath. So I'm going to go to Actions and go to Generate, right? And you can see it's generating the G-code, and it's already generated the G-code. It's a small model, so it's not going to take a long time. Sometimes it's very helpful to look at the G-code, and so we can go to Actions and Simulate Toolpath. Now, I don't like to use it here. I like to go down here on the browser and right-click and go to Simulate Toolpath, and there it is. Okay, so we can zoom out, and you can see right now we're at layer 1, which is 0.3 millimeters in height. You can see that layer is going to take 199 seconds to print. Okay. And we can either use the arrows to go up through each layer, and notice that they go in layers of, looks like about 23 layers or so, and we can go all the way through. So we can see what's happening in the middle of the build. You can also use this, the arrow to automatically take you through this. If we go up here all the way to the top, you can see that there's 223 layers. That's going to take 2,536 seconds, which is about 40 some odd minutes, like that. All right. If I hit cancel here, right, and takes us back out to this. So we've generated the toolpath. We're ready to create the G-code. Okay. So to create the G-code, we're going to go up to Post Process. So I click on Post Process, and the area that we want to fill out starts on the program. So the program name right now is 1001. I don't like that name. I'm going to choose Cowie Bunny-1. Okay. The output folder is very important because you want to be able to find your G-code when you're done. So I'm just going to click on this, and I'm going to choose my 3DP model folder in my EGN 150 folder on my hard drive. So I'll select that. All right, and you can see that right there. And we're ready to go. I'm going to check. Actually, I'm not going to check this. I'll open it manually because I'd rather show you that way. So I'll uncheck the OpenNC file or OpenGcode file in the editor. I'll uncheck that. And instead of saying OK, I'm going to choose Post. Right? Post means it's going to create the G-code. If you say OK, then you have to go back again to post or create the G-code. So it's just shorter if you go through Post right here. There it is right there, and I'll say save. And let's bring this over now so we can look at it. All right, so there's my G-code. I'm going to open this just to show you what this looks like. This is an ASCII text file, so I'm going to right-click, and I'm going to open with, Notepad. Now, if Notepad doesn't pop up here, just go to Choose Another App. Choose More Apps here and choose Notepad. If you always want to use Notepad to open that, then click on that, say OK, and then there's our G-code. Now, we're not going to go through all the details of G-code. There's plenty of websites where you can find all the information on what all these codes mean. Basically, this is just instructions for the 3D printer. There's a lot of X, Y, and Z instructions for how the print head is being instructed to move to create each layer. You can see it's a rather large file. Okay. It looks like there is, well, I can't even see how many lines of code there is right here. There's a lot of code, right? But we don't need to go through that. The print time, as I said, is 42 minutes and 17 seconds. So we're ready to copy that to the flash drive. bring it over and insert it into the Creality 3D printer, and then start your print. All right. So if you have any other questions, please talk to me in class.